Hi, hello everyone. Myself Aditya Bijay and my team member is Digbijay Pal. We are currently pursuing MCA at Chanakya University. Today we are going to explain the research paper about heart disease identification method using machine learning classification in e-healthcare under the guidance of Professor JB Simha. We have taken this paper from IEEE website. Abstract. This study aims to develop a machine learning based on classification of model for accurate identify the presence of heart disease using patient data, leveraging healthcare datasets and classification algorithms. The system enhance earlier diagnosis and support decision making in electronic healthcare means healthcare systems. Introduction. Important of earlier detection of heart disease. Heart disease is the leading cause of death worldwide. Earlier diagnosis can prevent complications, reducing healthcare costs and save lives. Timely treatment improves several and quality of life. Rule of e-commerce and digital diagnosis. E-healthcare use a digital platform to provide remote health services, allow for real-time monitoring, faster data access. Advantages of machine learning in healthcare. ML can analyze large amount of patient data quickly and accurately, detect hidden pattern that may not be observed to humans, improve diagnosis accuracy, predict risk, and support clinical decisions. Objectives. Build a classification model to detect heart disease. Datasets. We are used heart disease datasets consist of 1025 insights and 14 attributes was utilized like age, sex, chest pain type, resting blood pressure, cholesterol, fasting blood sugar, electrocardiography result, maximum heart rate achieved, slope, old peak, heart stage, and last target. Data preprocessing. Handling missing values. There are no missing values in the dataset we are used. Future selection, correlation analysis, heat map correlation, pair plot. Model training and evolution. Here we split the data into two parts like training and testing, 5-fold and 10-fold cross validation, matrices, accuracy, accuracy, precision, recall, F1 score. Machine learning models used random forest, SVM, Navy bias, decision tree, KNN, logistic regression. Here is the accurate value and precision. At first, we used model forest, random forest, and the accurate is 98%. And next, we used SVM, and the accurate value is 88%. Navy bias, that is 80% accuracy. Decision tree 98% accuracy. KNN 79% accuracy. Logistic regression 79.51% accuracy. Conclusion. Machine learning can effectively identify heart disease, improve diagnosis, accuracy and speed in healthcare. Future work used larger data sets, deep learning and real-time IoT integrity. Thank you. Next my teammate Digvijay will continue.
Hello everyone, myself Digbijay. I am going to continue with the coding section for our research paper. So we are using Microsoft Collab. We can also use Jupyter Notebook in our native systems. Both works fine. So here first we have imported all the required libraries such as pandas, numpy, matplotlib, seaborn, and all the other things which we have used throughout. Then we have imported the file that we have used for sampling. Then we started with exploratory data analysis. Here we have first given df.head so that we can check the initial 5 columns, whether, sorry, rows from our file, so that we can see whether those are displaying or not. Then we are using df.info, which will give what kind of data types are used in each of the features or attributes. So in this columns, say for suppose age, it's integer type. For sex, it's integer type. For CP, it's integer type. In the same way, or most of them are all integer type except the old peak, which is a floating type. Then we went with df.sample for again showing some samples from our data set. So from there we have given here 8, which will give us only 8 rows. We can change it and make it 10, 20, whatever we want. Then it will show those many rows. Then we have used df.describe to describe our data. So here first, this first rows is saying count, that is our number of instances in our file. There are 1025 instances and 14 features or attributes in our dataset file. Then the second row is mean. It will give the mean of all these this complete age column. In the in the same way, mean for the second column, third column, fourth column. Then we have STD, that is standard deviation, for each column. Then minimum of each column. Then 25%, 50, 75%, and then maximum. Then we have used df dot is null. This one we have used to find any null values. Is there any null values in our data set? Since our data set contains all numeric data, so numeric data, and also it has no null values, so it is showing all 0. Later we have went with visualization. So we have visualized this data in box plots. From this visualization we can determine which where the outlier lies, like for each column and each attributes, which where the outlier lies from which range to which range. After that we have went with IQR method, that is interquartile range. This is upper bound and lower bound we have used to get whether there are any outliers in the data set. So in our data set, these columns have outliers, those with the values, and other which don't have any outliers are marked with 0. Then we have did the pair plotting for plotting our data according. We have taken age, cholesterol, THL, THALACH, old peak, target. Though we have taken this in accordance with target only, so that's why hue is the target. Target here denotes like 0 and 1, which is blue and orange. 0 means the person has no heart disease, and 1 means the person has heart disease. This is a scatter plot, that's why these are shown in this way. So after this we have went with heat map for correlation. Then for visualization of feature relationships with target, we did this comparison for chest pain type versus heart disease. After that, we have did another bar graph for mean cholesterol by target error. Here 0 denotes if a person is healthy, it will be denoted by 0, and if the person has a heart disease, then he will be denoted by 1. Then after that, we did feature and label separation. Here we have did the data frame dot drop for dropping target, which is the last one in our data set. There are 14, as I said. So target we have dropped because all these results, like all the other variables, we want them in accordance with target. Whether the person has uh, has a heart disease or the person doesn't have a heart disease. So in that way, we have taken target as the x and all the other as y. So in accordance with x only, all the other features that we have will be used. Then we started with splitting the data. So we started with training the test split. Then we did feature scaling, which is required for SBM and also for KNN. Here we have used standard scalar. Then we started with modeling, or we used the algorithm. We started testing. So first we did random forest, then we did support vector machine, then naive bayes, then decision tree, k nearest neighbor, that is KNN, and then logistic regression. Once these things are done, we have did the modeling. So for modeling, we have taken this. Then after modeling, we run these reports so that we can know which model is giving better results. So from this, we have made another table so that we can get all of this in one eh, accumulated in one table. So for that, we took a result as an array and then we have put all the things in that. So in that way, we have created another table for each model, so here random forest with 98% accuracy is performing the best out of all the other algorithms. Like, and for SBM, it is 88%, naive Bayes, it is 80, decision tree, it is 98%, KNN 79%, logistic regression is 79%. Then we have went with validation. So we did 5-fold validation and 10-fold validation, and with that also we got an accuracy of, for 5-fold we got an accuracy of 99%. For random forest, for SBM we got 70%, naive Bayes we got 82%, decision tree we got 99%, and for KNN we got 68%, logistic regression we got 84%. Then we did cross validation for 10 folds. So random forest we got 99%, SBM we got 68%, naive Bayes we got 82%, decision tree we got 10%, and KNN we got 69%, and logistic regression we got 84%. There is a small positive and negative. We can see these things are like precision, like how much mistake this number can have. So it's plus and minus, so it will be within that range. If we plus this value with this data, the value we get with plus and minus, that will be like the range. After plusing this, we will get one value, and after negative we'll get another value, so within that range. So this one we have basically did without uh, after we found the outlier, we have not removed the outlier here, because for medical things, outliers should not be removed, since there are rare conditions which should not get removed. So for that, in medical field, we generally keep outliers. But we have also did this whole modeling without an outlier, that is with by removing the outliers that are available in the data. So for that, we did the similar thing. First of all, we have again imported all the required libraries. Then we have imported the file. It's the same file. Then we again started with exploratory data analysis. The same, we have taken the info. Then we did the sampling. Then we have described what data are available. Then we checked for null values, whether any null values are available. Then we did the box plot. Then with IQR, we found whether any outliers are there. Like the previous, we found the outliers, but this time we removed the outlier. So once we found the outlier, we started with box plotting those outlier. So for particular, as we can see, uh, for particular columns only, we got the outlier. Not everyone has outlier. So we box plotted for those particular which has outlier. So these are the ones which has outlier. So after that, we have tried with a table, which will give us the outlier, which table, which datas are actually having outlier. We have given a table of that. Then after that, we have analyzed if there any skewness found in the outlier. After running this, we found that if we see the graph, we didn't found any skewness. Datas are overall in a good position. They don't have any skewness. So we went with replacing the outlier. We took the mean or median of the column. We took that method to remove the outlier. So after that, once we remove the outlier, we again checked whether there is any outlier available. So as we can see, the first time we had outliers here, but once we have removed the outlier using the mean or median method, uh, the outliers have been removed. But one outlier, still some outliers was available in the old peak. So we further removed outlier using the IQR, lower bound and upper bound thing, and then there was no outlier available. And after the removal of outlier, our data frame shape was in this manner. Earlier, it was having 1024 instances and 14 attributes. After removing the outliers, our data set reduced to 1015, and the columns remain same, that is 14. After that, we started box plotting. We again did the box plotting once the outliers are removed, and as we can see, there are no outliers shown here. So after that, we have again did the pair plotting, scatter pair plot. So it shows this one is different from the earlier one that we have did. It's showing differently on some sections. And then we again did heat map. Then we went with visualization of feature relationship with targets for both this chest pain type versus heart disease and average cholesterol level by heart disease status. After that, we have again mm, showed the number of processing and after pre-processing, we have dropped the target, then we have splitted, and then we started with in all the algorithms. Then we have generated the reports, which model has given the best accuracy. The reports are almost similar, with outliers removed. So random forest is still the best one, 98%. And with removing the outliers also, the random forest accuracy we got 98%. And others also remained almost similar. And after doing the cross validation also, the results are similar. So that's all. Thank you everyone.